Okay, good afternoon, students. Let us start with the lecture. So in the last lecture, we studied three different techniques of the machine learning. That is logistic regression, then random forest, and also support vector machine. So these three techniques we studied into the last lecture. So logistic regression, it means that here this is one of the modifications, or we can say follows the linear model for model building, so for the classification. And here the step by step the plan is made in order to give the model. So this is also supervised learning algorithm for classification. Next, we see support vector machine. So where we are using a concept of hyperplane in order to go for the classification, as well as support vector machine is also used for the regression. And next we see in the random forest. So random forest, just like this is a collection of multiple other techniques given into a single technique. So here random forest makes use of decision trees, that is multiple decision trees are combined together to go for a classification. So okay, just like decision tree is also used, decision tree, just like decision tree categorized my given data item, similarly the random forest as well. So this we have studied into the last lecture. So now let us go for the next point, that is classification errors. So classification errors. So here in this chapter, we are learning about classification as well as the regression. So let us take what is meant by errors into the regression first in short, and then we will go for errors into the classification or classification errors one by one. So here regression, it means that I'm predicting some value. Okay, that is just like yield of some crop. That is, I wanted to calculate some predictions, or I wanted to calculate some values. That is, a regression involves predicting a continuous valued output, that is a response based on some input. That is, some features or predictors we will use, and whatever difference between the actual value and predicted value, that will be called as a residual. It means that this is a difference between my predicted value and the actual value. So this is done in terms of a training data. So training data, whatever in sample data. So this is another word used for the training data. जो काही माझा ट्रेनिंग डेटा आहे त्याच्यानुसार समजा in case of training data we are having input as well as the output. Okay, so if consider I'm having set of inputs and I'm predicting some values, and that value is differ from the actual value, then that will be called as a residual. So residual, this is used for the each data points, and whatever residuals refers, that is residuals we are referring, this is a collectively, it means all the values whatever training sample data difference is there, that will be referring to the all differences whatever we have predicted. Okay, so if consider I'm having training data as 10, and out of that I'm calculating the residual for 10. So collectively this 10 residuals, this 10 residual will be collected into a residual. Okay, so but when it comes to the new data or test data, which is completely a never seen data before, then that is called as prediction. If consider in case we know the actual answer, but in case of new data or test data, we know about the actual answer, and that's why this will be called as a prediction error. Okay, this is in case of regression. So these can be, that is residual and prediction error. These can be the two terms which are related to the errors in regression. So now let us go for errors into the classification. Okay, for simplicity, I will take an example of the binary classification. Binary classification, it means that the complete item set, I wanted to divide into only two categories. That is, it belongs to some class 0 or class 1. For this example, we obviously have taken this example previously also. That is detecting whether email is spam or not. Okay, so here instead of talking in terms of class 0 and class 1, consider that positive, it means that the email is spam. That is, right now we are detecting whether email is spam. If email is spam, then I can say that this comes under positive category. And if consider email is not spam, so here another term used is ham. Ham, it means that it is not a spam. So then the word used is negative. That is, I can consider this as class 0 and this is class 1. Instead of that, right now here we are using positive case and negative case, or positive classification and negative classification. So here we wanted to detect whether email is spam or not. So what is mean by errors in classification? So consider that this is the scenario that positive, it means my email is spam, and negative, it means that I'm detecting that the email is not spam. Okay, so here this is my result of prediction. पॉझिटिव्ह म्हणजे मी माझा ईमेल पॉझिटिव्ह और ईमेल स्पॅम आहे असं प्रेडिक्ट केलेलं आहे. So then here, okay, you might be getting, you might be feeling that these terms are familiar. Yes, we have studied these terms during the first experimentation. That is iris class of for flower classification. But still, as this is a part of theory, let us revise these terms. So here, if a model predicts an incoming email as being spam, so it is really spam, okay, then that is considered as a true positive. Okay, so here true positive, it means that my email is spam, and also I'm detecting or predicting that is my model is also predicting that this is the spam email. Then this case will be called as a true positive. Then positive, since that is model predicted spam, that is positive, it means that this is a result of my prediction. Okay, positive and negative, these are the results of my prediction, and true and false are the actual values. Okay, so true, positive, it means that the email is also detected as a spam, and also it is a spam. So here positive, since model predicted the spam as positive class, and true because the actual class matched with the prediction. So this is the first case. Second case, that if consider the email is labeled as spam, okay, it means that the email is spam when it's actually not spam. Okay, so here my algorithm or my model is considering the incoming email as spam. Okay, but actually it's not spam. Then that case is considered as a false positive. Okay, here positive, it means that this is output of my model and this is the actual answer. Okay, false is my actual answer and positive is the answer predicted by model. Okay, and this case, that is false positive and true positive, these are the two cases here whenever we are detecting whether the email is positive or not. Okay, so then next case, based on this, here this was the case regarding the detecting whether email is positive or not, sorry, email is classified as positive, but whether it is positive or not. Okay, so that was the case. So based on this, there are 4 types of the that is whatever my data is there, that falls under 4 categories. Okay, so given this, we can see the results of classification model on new data can fall into 4 potential types. First is true positives. True positive, the actual, that is algorithm has declared this as a positive, and in actual this is also spam. Next, my model predicts them as a positive, but actually it's not spam. Then this type of error is called as a type 1 error, false positive. Next one, true. It means that this is actually a spam, but I declared this as a negative. Sorry, true negative, it means that here I'm detecting that, sorry, here my email is not spam. Okay, that was the negative. Then true negative, it means that actually it is not a spam. Spam nahi, true ahe, and still it is a negative. Okay, let us continue. So here, so true negatives, this was the third case. And next one is that false negatives. False negative, it means that here the another type of the error, that is I declared this as a negatives and actually it is a false. So here these are the 4 types, and this last one will be called as a type 2 error. Okay, so whatever these 4 cases are there, so true and false refers to whether the actual class is matched, that is whether this is matching, this is not matching, this is matching with the negatives, and this is not matching. Okay, matched with the predicted class. And positive or negative refers to which classification was assigned to an observation by the model. Okay, so this was regarding the 4 types of the classification types, and out of that this one will be called as a type 1 error, and this will be called as a type 2 error. False positive, here the positive, it means that I actually my model given this as a spam, but it's not. Okay, and in case of this, actually my model given this as a negative, that is this is not a I said that it means as per the model this is not a spam, but this is actually a spam. Okay, false negative, that is actual type is not matching here. Okay, true it means that these observations are correct. I declared negative, and also it is also negative. So this is also positive, and it is also matching with the actual class. So these are the 4 types, and out of that, these 2 types will be called as a type 1 errors and type 2 errors. So for clearly understanding this? So here I've taken example of a cat classifier. So let me show you the slideshow. Okay, so here consider that these are the sample images which are given as input, and out of that we wanted to classify which are the cats, that is whether this the given picture or given animal belongs to the cat classifier or doesn't belong to the cat classifier. Okay, that we wanted to decide. So based on this we observed the result. Okay, during the observation, whatever the four cases are there, that is true positive, true negatives, false positives, and false negatives. Whatever these four cases are there, that we wanted to put into some matrix. Okay, and for this purpose, that is for the binary classifier, a confusion matrix is used. Confusion matrix, it means that this is a maintaining the track that which are my four cases belong to these four categories, or which are the data items which belongs to these four categories. At a time, my data item can belong to the either of the categories. So here confusion matrix is used in order to give this clear chart. Okay, for example, here this is my actual class, that is and this is a predicted class. Okay, so for 700 samples which are actually cat and also predicted as a cat. Okay, it means this is my true positive. Next, this is actually a not cat. Actually, but as per the prediction, the model categorized this as a not cat. Sorry, this as a cat, but actually this is not cat. So can anybody tell me this 100 belongs to which category? Out of these four cases, to which case the 100 value refers to? Just like this one. This belongs to the true positive. Similarly, this one. Okay, first consider what is my prediction. My prediction is this is under cat. Cat, it means that my output is positive. Okay, but this is not cat. It means that the prediction is not matching. It means that I should add the false there. It means that this 100 belongs to the false positives. Okay, false positives, it means that here the model gives this as a positive, but the actual class is not matching with this. False actual result and the predicted result is not matching. Whereas when it comes to the 50, okay, 50 is actually categorized, that is the real category of this 50 items. 50 cats is cat, but the model predicted this as a not cat. So to which class or which category this belongs to out of these four? Of course, I removed two true positives, false positives. So which category this belongs to? Okay, I will declare. This is actually false negatives. Negatives, it means that here not negative, it means this shows the output of my prediction. Prediction is my negative. Positive, it means that I added this item to the cat category. Negative, it means that I had not added this item to the category of cat. So positives, I added this item to the cat category, but it's not. false negatives, I actually said that the item is not cat, that is negative, but the result is not matching, and that's why false. False, it means that this will be a false negative. True negatives, it means that I categorize or model categorize them into the not cat category, and also this is a true result. Okay, so this will be true negatives, true positives, false negatives, and false positives. Okay, so this is my confusion matrix for the cat classifier. And so this is actually the main basis. That is, I wanted to check the performance. That is performance. It means that how the given algorithm works. We wanted to calculate the accuracy. And for this purpose, the confusion matrix is at most needed. Okay. So here you might be thinking, what is use of this? Okay. This will be used. So here it means that here we can make the conclusion that at this category, it means at this point we are right. At this point also we are right. But when it comes to the 150, our results are getting wrong. It means that if I wanted to improve my algorithm or my model, I should improve at these 2 points. Okay, that is 150. So we wanted to check because of what we categorize them into not cat, even though that is why we categorize those into cat, still it is not cat, and why we are unable to categorize them as a cat. So for this purpose here, that is we might make some conclusions. That is, on reviewing these examples, we identify that following seems to be common across erroneous cases. That is, white cats are not being correctly identified. So whenever there is a white cat is there, we are unable to check whether that is cat or that is dog or some belongs to the other category. Okay. So here, white cats are not being correctly identified. That can be one problem. Second one, dogs like cats being identified as cats. Okay. So this can be the another case. Some dogs which just look like a cat, those will be identified as a cats. And third can be the reason is dark background leads to the misclassification and so on. So here, because of these three main reasons, I'm losing the accuracy of my algorithm. So for this purpose, we wanted to improve or we wanted to check the performance. So for performance checking, we always take accuracy into the considerations. So here we will check how we are getting or out of errors, because of what reason we are getting much more errors. Okay. So here for our cat classification example, it looks like that is below page that whatever data points we are having, that is white cats, we are having 27 cats, and out of that, it means 150 errors we have given. Out of that, 18% errors lies into this white cats. Dogs like cats being identified as cats, those there are 28 samples, but out of that 18.7%, this was the error that is we found out. Then because of dark background, there are 61 samples are there which are having the dark background, and 40.7% of the total errors, these lies within this because of this reason. Okay. And Sphinx cats, for that we are having 22 samples, but 14.7 this percentage of the errors are there. So here we wanted to calculate the accuracy. So accuracy, it means that overall fraction with tag misclassified, we wanted to check. So cases with errors and total such cases in the data set. Okay, that will be the accuracy. So here we chosen the area, that is at this point we wanted to perform or improve at this point. So here it means after choosing these areas, that is we can perform the basis of feasibility, where we needed efforts, and what can be the importance of improvement in that area. It means how we can improve our data samples, or how we can go for overcome the existing drawback that was the necessary. So most accuracy that can be achieved in that area, that is collecting more data points for cases where errors are happening. That is whatever my dark background images are there. So we can go for finding much more dark images, images with the dark background, and then modify our model so that it will still capture the images or still give the correct prediction even the dark background is there. That is, it means we can apply some filters on that that images and check how to identify the cat from that. Okay, then augmentation of data or steps to improve the data quality. So use other ML models or tune hyperparameters differently. It means here not only the pre-processing is required, even though we can go for applying some other ML techniques as well, other than the existing points, existing steps. So this was regarding the previous case. So primary, it means there are multiple ways to classify the errors. So the primary, it means basic types of errors. There are two types of the errors are there, that is in sample and out of sample errors. In sample errors, it means that we can refer to this as a training data, that is errors into the training and errors into the testing. Okay, in sample errors, these are also called as a resubstitution errors, are the error rate found from the training data. That is the data used to build a predictive model. So whenever whatever problem we are having into the training data, that will be called as in sample errors. And whatever out of samples errors are there, so these are called as the generalization errors. And that is are the error rates found on new data sets. So whatever test data is there, that is exactly our new data, that is never seen data. So these are also called as generalization errors. And these are the most important because right now, whatever our algorithm is there, we obviously, when it comes to the application, we apply on the completely new data set. And that's why here, that is finding new data set and are important since they represent the potential performance of given predictive model on new or unseen data. So even though training data is used in order to train the model, but actual application of model is based on the test data only. Test data, it means that how it can work or correctly predict the test data, prediction of based on the test data. Then only we can say that that will be a success or real application of our model. So in sample error rates may be very low and seem to be indicative of high performance model. But one must be careful. That is, here we wanted to avoid overfitting. Okay, overfitting, it means that my model works correctly with the training data, but it doesn't work with the test data. So that also we do not want to happen. Okay, which would result in a model that is unable to generalize well to new data. We wanted to generalize the new data as well. Okay, generalize, it means that increasing the accuracy. So here, let us see which are the measures. Major, it means that error trale, but how errors we can use. So accuracy is the key measure of the performance and is more specifically the rate at which model able to predict the correct value. Okay, let it be classification or regression. Accuracy म्हणजे काय की माझा मॉडेल किती accurately work करतो, that I wanted to calculate. Okay, the correct value, predict the correct value. Just like if it is cat, it should be able to categorize this as a cat. If it is not cat, then I'm categorizing them into not cat. Then that will be the correct prediction. Regression, just like if I'm predicting that this year I will have yield as a 40,000 and I'm reaching around in the same range, then I can say that That is, if I'm also earn 40,000, it means that that is the correct prediction. If instead of 40,000, if I earn 41,000, then that 1,000 difference will be called as a residual. Residual in case of training data म्हणजे मला माहिती होतं की माझा आउटपुट 41 will be there and still my algorithm predicted 40. In case of training data, that will be called as a residual. And if we are working on the completely new unseen data set, then that will be called as a prediction error. So accuracy is the proportion of correct predictions out of all predictions made. Okay. Prediction, let it be positive or negative prediction. If both are correct, then that will be comes under that summation divided by all predictions, just like here. Okay, here under this category, I made the correct prediction. Under this category, I made the correct predictions. So my accuracy will be 850. The combination of these two, the correct predictions are made, divided by summation of all these predictions. Summation of 700 plus 100 plus 50 plus 150. 200 plus 800, total 1000. It means that 850 divided by 1000. It means 0.85 will be the accuracy of the existing model. So here the two matrix from the confusion matrix are precision. That is precision is the first we wanted to predict the value, is the ratio of true positives to the total amount of positive predictions, that is true or false. Okay, so here with respect to the accuracy, we are having two terms, that is precision and recall. So precision, it means that I have calculated the value as a positive. Okay, let me show you the concept. I have predicted the value of positive, that is cat is positive. It means that the cats which are categorized as positive and those cats which are not cats but still categorized as a positive. So 700 plus 100, 800, that is a interested value, divided by total amount of, that is positive predict value is the ratio of true positives, that is 700 divided by total amount of positive predictions, 700 by 800. So that will be the precision. Okay, so precision measures the proportion of accurate positive predictions out of all positive predictions made. Okay, so here this is a precision, that is how correct my algorithm can be. And whereas next one, this concept is recall. So here, this is the ratio of true positive to the total amount of actual positives, whether predict correctly or not. Okay, so here it means that this 700 divided by 750. Okay, so actual my 700 cats which are categorized as cat, and recall, it means that 700 divided by the total number of the cats. Okay, so what your true values are there, those will be taken here, and 700 divided by 750, that will be the recall here. So based on this, there is one more parameter, that is a matrix is associated, that is the F score. This is also called as a F1 score. So this combines the concept of accuracy, precision and recall into single model, and it performs the weighted average. Weighted average म्हणजे precision ला किती महत्व आहे, recall ला किती महत्व आहे. So it means that each one is contributing in different way. So in order to produce a single measure of performance based on the simultaneous values of both, so this value will be ranging from 0, that is worst case, to the 1, that is best case. So F score, this gives the actual performance measure between 0 to 1. Clear with this? Please read the slide contents. So here, difference between accuracy and recall is that here we are using the actual positive cases, that is actual true positive divided by total positive predictions. Okay, so here the positive predictions we are using, and in case of recall, the actual positives, it means which are actually cats. Okay, let it be the algorithm declares them as positive or negative. So both we out of that, true positive will be taken as a numerator, and denominator will be the actual number of the cats which are there. So, okay, so that is the difference. You might be getting confused both at both positions. We can see true positive divided by positive. So here the actual positives are used, actual positives, actual cats, and predicted cats. Okay, predicted cats. So these many numbers, this will be used in terms of precision, and this will be used in recall. Actually, my machine screen is not matching with my explanation. Wait a minute. Ah, yes, here I was. So, okay, accuracy, it means that 700 plus, precision, it means that 700 divided by 700 plus 100. So this one divided by this one. This will be my precision, and this one divided by complete this one. This will be my recall. Okay, so mathematically combining these two will be done into F-score calculation, and F-score will have a value ranging from 0 to 1. So where 0 shows the worst case and 1 shows the best case. Clear with this? Any doubt? So now let us go for the next point, that is analysis of time series. Okay, so before that, directly moving to the analysis, that is the subtypes of the analysis: linear systems analysis, non-linear dynamics, or rule induction. Let us go for some time series introduction. Okay, time series. Series, it means that we can say a sequence. Sequence, it means that which comes under one by one. So similarly, time series, it means that I'm talking about this, that is just like second semester of the students, then one day, first day, second day, or the number of days I have taken a lecture. So it means that this will be called as a series of time, that is from 1st of March to the May month. This time duration, whatever the period is there, so this continues during this period. If I'm calculating something or observing with change of time, then that will be called as a time series. Okay, so in broad form, that is analysis in terms, an analysis is conducted to obtain the inference what has occurred in the past with the data point series and endure to predict what is going to appear in the coming time. Okay, instead of going for taking the example of lecture, let me take an example of the existing. It means real life. So previously, it means that the few years back, we are having the petrol ranging from 60 to 65 rupees per liter. Okay, but right now we are having the rate crossing 120. So it means that I can say that before 5 years or before 3 years or 4 years, this was the rate, and right now we are having this as a rate. It means that we are talking in terms of time. Let it be some price or let it be some production. That is, initially I was able to read this much during this time, but right now I can read only this much, or the capacity is more, etc. It means that here we are talking about some past event, that is some measurement data points. And right now also we are talking about those data points value, but with respect to the time, past and current, or past and then. On this basis, we might decide that in future this might happen. Okay, so here it means that we are predicting some values based on the series. So in short, it means in the introductory part, I can say that then ordered a set of observation with respect to the time period, it's called as a time series. That is a sequential organization of data according to their time of occurrence is termed as a time series. Okay, time series, it means that I will analyze just like how many students reported today, how many reported tomorrow, or how many will report day after tomorrow, etc. It means that here I'm talking with respect to the time and some values and making some predictions. So when we talk about time, it means that this is a just like a physical quantity. Physical quantity, it means that right now the physical dimension, or it means that this is having some effect on my data. So a time series data is set of measurements taking place in constant interval of time. Here time acts as an independent variable. ओके, असं नाही की म्हणजे हा याच्या बेसिसवर मी तो फॉर्म्युला मध्ये कुठेतरी ऍड करते आणि किंवा त्याला ऍज अ एक व्हेरिएबल म्हणून यूज करते. नो, हियर we are taking values of data with respect to the time, but at a specific interval, but that data doesn't have time as a effect. म्हणजे डेट ही आली म्हणून एवढं सेल होईल किंवा डेट ती आली म्हणून एवढं सेल होईल. नो, हियर date or time is not acting as a dependent variable. It is always a independent variable. Okay, so this can be independent variable, and the objective to study changes in characteristics is dependent variable. म्हणजे माझा डेटा चेंज होतो तो मला इंटरेस्टेड आहे, किती टाइम जातो किंवा टाइमच्या बेसिसवर माझा डेटा कसा चेंज होतो, दॅट इज इरिलेव्हंट. ओके, टाइम आहे, बट माझा डेटा जो चेंज होतोय दॅट इज द डिपेंडेंट व्हेरिएबल. फॉर एक्झाम्पल, sales increased from 90 to 91%, or profit we are having in terms of 20,000 to 30,000, etc. So it means that these measures or these variables are required, but time is at all not a part of this model. Okay. For example, we can measure the sales on daily basis. We can go for companies profit per quarter. That is here. I wanted to, based on the annual quarter of previous 2 years, I will check how much profit will be there in the first quarter, second or third, etc. Okay. The next annual changes in the population of a country. Yes, here also with respect to the time, we can say that how this is increasing or how the changes are there. But time doesn't control population. Okay. Then consumption of energy per hour, etc. It means that whatever these sales or profits are there, or population is there, or consumption of energy is there, या सगळ्या ऍट्रिब्यूट्सला टाइम मॅटर करत नाही, म्हणजे टाइम त्यांच्यामध्ये कंट्रीब्यूट करत नाही की माझा सेल्स वाढावा वगैरे. ओके, बट स्टील वी आर ऑब्झर्विंग रिस्पेक्ट टू द टाइम. So here, when it comes to the time data, that is time series data, this can be of 3 types. First is time series data. A set of observation contains values taken by a variable at different times, etc. Just like I wanted to calculate the growth of a plant, or just like production. That is, in the first month, I produce this much. In the second month, produce this much, etc. It means that some observations or some calculations we are performing, or some values we are getting. This can be one type of data. Second one, cross-sectional data. So here, data values of one or more variables gathered at the same time point. Okay, it means that, for example, cross-sectional data. Okay, for cross-sectional data, I cannot come with the example. Can anybody suggest cross-sectional data? Okay, one or more variables, it means that, consider that I wanted to calculate sales of a computer or sales of a cell phones. Okay, with sales of cell phone, if I'm calculating that reduction of the textbook sales, okay, it means that here I'm observing 2 variables. माझ्या cell phone चा sale किती वाढलाय, or I might be relating that to the some another variable, just like a textbook sales or some newspaper sales or a TV or another materials, etc. म्हणजे काय की माझ्या एका व्हेरिएबल पर समजा दुसऱ्या व्हेरिएबलचा पण मी स्टडी करते at the same time, then that will be called as a cross sectional data. And the last one will be pooled data. Pooled data, it means that a combination of time series data and say time series data and cross sectional data, that is both we are combining together. Okay, so this will be a pooled data. So here, when it comes to time series, we can represent this in terms of data visualization techniques. So just like this is a bar chart, or this is a pie chart, circular, etc., or sigmoid, or bar charts, etc. Then in vertical, horizontal, or waveform, etc. In this way also we can show the time series data. So this will be used in order to uncover the hidden patterns, that in this month this hike is there, or this is having at the highest point sales of this item is more, or at this point sales of this item is more, etc. It means that here I'm making some conclusions, or drawing some patterns, or withdrawing some hidden rules. So okay, so up till now we studied time series data, time series analysis, but when it comes to the statistics, that is right now we wanted to perform the analysis of this data. So time series analysis is the statistical techniques dealing with time series data or trend analysis. So it means trend analysis, it means that we wanted to change or we wanted to check which things change with respect to the time. That will be called as a trend. Okay, so this analysis will be also called as a trend analysis. So a time series contains sequential data points mapped at their certain successive data duration. It incorporates the methods that attempts to surmise a time series in terms of undertaking either underlying concept of data points in the time series or suggesting for making the predictions. So we wanted to check whether any cycle of trends is getting repeated, or do we come to the same state after duration of period, or we want to check some weather or some price hike or some stock market, etc. It means that just like we are having the, when it comes to the crops, so certain crops price hike during some period or get slow during some period. It means that we wanted to check how this data get flows. So then that will be called as a time series or repetition of the same sequence or repetition of some predictions, or that is repetition of some or not only repetition, even though we can go for the prediction as well. Just like right now, based on the 4 years analysis, if we come to the conclusion that petrol prices are increasing at this rate, then we may guess that during the coming year, this might be the price of petrol, or petrol may reach, prices may reach up to this point, etc. So it means that we are making some predictions. So this is how the time series is used. So regarding its subtypes, we will see into the next lecture. Please don't leave the meet. Let me take the attendance. During this period, if you're having doubt about the classification errors or time series analysis, you can ask. I'm still on. Okay, those who are attending lecture offline, they can write the roll number, your roll number respectively.